Chapter 7, Section 2.1. So we're going to talk about transforming trigonometric graphs. So it works the same way that it has for other functions that we've moved around. So if you think of transforming, easiest one to describe is like when we had our parabolas. Remember when we took our parabolas and we flipped it upside down? Right? That's a translation, right? Or if we took our parabola and we moved it left or right or up or down, or we made it stretch or shrink or, expand out. Those are all examples of transformations. So we're going to do the same thing. And this first one we're going to focus on our sine function and how to sit there and take our sine function and move that guy around. So you guys will be playing around with Desmos here shortly, right? But before we get onto just the sine, so here's kind of like that nice long kind of explanation of a sine function. So ultimately by the end, we'll be able to look at that a, and we'll be able to explain what a does to our sine function, what that h does to our sine, and what k does to our sine. And those all look familiar, don't they? Hopefully, like those graphing forms of those quadratics. And maybe, can't say, it might work the same way. So you'll do a little exploration on that to find out. All right. So before we get working on our sine function, I have 4 graphs up here that we need to talk about. So we need to come up with an equation for each of these 4 and figuring out like what they all are. All right. So if we start with A, anybody know what this is?
360.
Yeah. What shape is it?
Circle.
It's a circle. Right? I bet you it's a special kind of circle.
Unit circle.
Yeah. How do you know it's a unit circle? Yeah, the ones, right? Those ones are telling us that we have a radius of 1, right? So radius from the center of the circle to any point on the circle is 1, right? So we know we have a unit circle. Does anybody know the equation for a unit circle? It's x squared plus y squared equals r squared. But since we have, well, I'll write it, r squared, that's for a circle. And then our radius is 1, so for a unit circle, we have x squared plus y squared equals 1. Yep. Oops. All right. You guys good with that? All right. So if I look at B and C, which 2 geometric functions do you think are represented by B and C?
Parabolas.
What trig function? One of them starts with a C and the other one starts with an S. Sine and cosine, yep. So these are our sine and cosine functions. So we just need to figure out which one is our sine and which one is our cosine, right? So when we graphed these the other day, we sat there and we pretty much started at 0, right? And we went all the way around the circle to 2 pi. And then we plugged in all of those values. So when we start this one, this is saying that at 0 degrees, or 0 pi, a radian of 0, our value is 0. So if I go over to my unit circle, and we're talking about this point right here, right? That's when my degrees is 0, or I have 0 radians. So that's a point on the circle. And what's the coordinate point for that circle? X is
1.
Yep, and y is 0, right? So when we've turned that into the graph, we're saying that when we were at 0, the value that we are graphing is at 0. So on ours, at that point, which one is at 0, x or y?
Y.
The y, right? And is sine or cosine our y values? Sine, yep. So this is y equals sine of x. Right? If we look at C using that same theory, right? So if we think of from 0 to 2 pi, that's us going all the way around the circle, right? So at 0, we start with the value of 1. So is it our x or our y that has a value at 1?
Y. Or sorry, X.
Yep, x, yep. And our x, is that sine or cosine? That's cosine, yep. So this is y equals cosine of x. Right? What about D? What do you think about D? What was the other trig function we talked about? Yeah, tangent, right? So this is y equals tangent of x. So let's talk about this little graph for a few moments. These little dashed lines that are through here, they have a special name, and they start with an A. Anybody? Yeah, asymptotes. Yep, good job. And does anybody remember the definition of an asymptote? So that asymptote is when this value can get really, really, really close, but it can never be that value of that dashed line, right? So last week we went through and we figured out the tangent going all the way around our circle, right? So for the fun of it, let's we'll go pink. Let's talk about the tangent at 90 degrees, right? So when it comes to our tangent, we want to do our y over our x, or sine over cosine. So at 90 degrees, that would be this point up here. And what's my xy coordinate for 90 degrees? So this guy right here. What's my x value going to be? Is that 0? And my y value is going to be 1, right? So y is 1 and x is 0. And what's 1 divided by 0? Undefined. So if we think of that 90 degrees, that 90 degrees is at like pi over 2, right? Woo! It gets me every now and then, right? So a pi over 2, or half a pi, is right here. So that dotted line is where that 90 degrees is. And at 90 degrees, we can't have a tangent value, right? Because we can't divide by 0, so it's undefined. So it is saying, like, those values are increasing until it gets to that pi over 2. But it can't ever be there. It can just get really, really close to it, but it can never be, right? All right. So tangent ones are always the cute little, they're the funny ones of them all, right? They're the ones that have those asymptotes. So usually if you have like, is this a sine, cosine, or tangent? Tangent's usually the easiest one to pick out. All right. So you guys are going to mess around with Desmos a little bit, and we're going to, for today, we're just looking at the sine function, and we're going to see if we can work on like translating that sine function. All right. And so ultimately, they want you guys to be able to write like an equation that shifts it up, that reflects it over the x-axis, shifts it 2 units to the right, and does like a vertical stretch. So let's think of back in the day when we had our little quadratics. Like if we had y equals x squared. So when you guys learned about these whole translations on going, we made you guys mess around with them a little bit. Like we had you guys take x squared, and I don't know, like you added 3 onto it on Desmos, and then you can make the connection between those two, what that does. Or you could put the x in parentheses and square everything, right? You could put a number outside of the x squared, and you could even make it a negative x squared, right? And then once we kind of went through and figured out how to kind of move these things around or make a connection between looking at our, what we're going to refer to as like our parent function, and then how each one of these affects that parent function differently. So we're going to do the same thing with the sine function. Oops, there we go. So for y equals sine, and I'm going to have you guys throw the x in parentheses, because when you guys go to look at, let's say, sine of x plus 2 and y equals sine x plus 2. These are two very different equations. This first one, you're taking the sine of that entire value, right? On this equation, you're just taking the sine of x, and then whatever you get from that, you're adding 2 onto there. Does that make sense? So to mess around with these, just make sure you kind of have that x in parentheses. Like, if you only had that x, you don't need the parentheses, but it kind of just helps with on Desmos when you go through putting in the different equations. All right. So what I want you guys to do is you're going to do the sine of x plus or minus some number and see what that does to the graph, right? Write that in your notes. Y equals sine of x, and then plus or minus some value that's not in the parentheses. That's going to do something different to the graph. Put a number or put something out front and see what that does to the graph. And do a positive and a negative and out front of the sign, right? So if you can define what each one of those do, then you'll be able to answer these little questions.